Because one of the things you want to know is, well, you're fixing the ice content at this one temperature. Well, I don't necessarily eat ice cream at 10 degrees Fahrenheit. It might be quite a bit warmer than that. So what this is showing me is, sure enough, this is the one with just the 3% fat, and this is the ice content curve. So what we have here is we go right on the y-axis. This gets colder, right? And as we go, on the x-axis, and as we go up on the y-axis, we have more ice. So if we look at this, as it gets colder, we get to a point we got so much ice that's in this product. But when we reformulated using our complex property that would calculate ice content and using nonlinear optimization, we were able to come up with an amount of maltodextrin that just put this freezing curve right on top of that. And this is how we came up with the fat-free ice cream that tasted like 10% fat ice cream. The first thing you do is you develop a descriptive analysis panel. You bring in people and you bombard them with all sorts of different ice creams and different products and different samples until you have them as an analytical machine, so you can bring in any product and they can score it and tell you what it's like and what's wrong with it and what's good with it. We tried the maltodextrin. It worked really well. We tried a lot of other things. And one of the things that didn't work quite as well as we expected, but would have worked better because we had some equipment issues, was freeze concentrated skim milk. And that worked quite well because we were able to take the milk solids, not fat content, or the skim milk solids was stuck at 11%. And you might go, well, why don't you use more skim milk solids in there? Well, skim milk solids contain lactose. And lactose, when you freeze ice cream, can crystallize out and give you this grittiness. So there's a limit to how much you can use. Plus, if you're using skim milk powder or condensed skim, it has an off flavor to it when you use high amounts of it. So what we did is we freeze concentrated skim milk to remove all the water, or a lot of the water, without screwing up the solids part. But a problem we had was we were going to double the amount of skim milk solids. We had to do something about the lactose. So we hydrolyzed the lactose, cut it into 2 molecules. Now you know, because I cut it in half, I've got double the freezing point depression problem. So it turned out for this product, we couldn't add any sucrose. We had to use a substitute sweetener. But since we were able to formulate for ice content and sweetness and other things, we were able to come up with a very high protein product that was very acceptable to this panel. And I think if we could have concentrated it a little better, we'd have had better luck. There are now other methodologies available for ultrafiltration that you can ultrafilter milk cold where you wouldn't have that problem. So we could make fat-free ice cream that's got twice the protein and a lot more calcium and everything else in it. And it all was because we understood the chemistry and we had the mathematics to lead to the right answer. Previous to doing that project, we worked on making a fat-free milk. And the first thing everybody said is, oh, you're going to have to worry about the flavor profile. Well, it turns out if you put skim milk under red light and have them compare it to whole milk, there's a large proportion of the population that can't tell the two apart. So it turned out all we had to do was make it whiter to make people think it had higher fat. And to fool the last little group of snobs that were able to pick out everything, we added a little bit of off flavor from milk. And that off flavor, oh, this is whole milk. You know, we had them go and we had to just add a little paint, a little flavor, and we had them fixed. But
a little light scatter, is that it?
Yes, and it turns out you can modify the size of the casein micelle and do a similar thing to scatter light. It's just not quite as effective. Well, let's look at something totally different. Reverse engineering. Reverse engineering is where it's a process of establishing the recipe for a finished food product using the following: a nutrition facts label, ingredient listing, regulatory requirements, chemical and sensory analyses, and expertise with the food product. There's many reasons you might want to do this. One is just so when you show up to a new client, you can ask them, is this your recipe? I don't recommend doing that, by the way. I got some people very angry. I did it on the plane. I reverse engineered it based on their ingredient listing, and I hadn't signed a non-disclosure agreement, and they wanted to know where I got it. The security people got involved. It wasn't nice. But to make a similar product, to see if another company is infringing on your patent, or to determine if a product meets regulatory requirements. Well, how does this work? This is a nutrition facts that was created using the TechWizard program, and it's the new format, see the big calories and everything. But the neat thing about a nutrition facts, when I look at them, it's a statement of composition. So it's what you want when you're done formulating a recipe. In our first example, we formulated for a composition, right, to make that 12% fat ice cream. The only difference is we're going to formulate for all this stuff, and now we've got added sugars. It makes it even a little easier. And we've got the actual values for these nutrients. So we can take this information as well as the ingredient listing, and there's a place in the software you just type all this in, and then you've got a composition. We're back to the formula development section, and you can see all these minimums and maximums have been set based on what was in that nutrition facts. Then we put in our ingredients based on order of predominance. Some of the ingredients are not going to influence the nutritionals, like the amount of this stabilizer and vanilla. But I know based on order of predominance and tasting the product, and if you have an understanding for the product, you can usually lock those in at levels that make sense. And then you just press the formulate button, and then you've got a recipe that's usually pretty close to the original. So, in conclusion, product development and daily production of fabricated foods such as ice cream or energy drinks is a complicated process that involves meeting many goals simultaneously. The first example demonstrated how to optimize a formula to meet sensory and compositional requirements, whereas the second example showed how to reverse engineer a formula based on its nutritional facts panel and ingredient statement. The use of software programs like this is really limited to really your ability to come up with equations like the freezing point depression equation and the ice content equations that we've developed at our software. Then you can truly formulate foods to meet any kind of requirements you might have. So, and that's pretty much it. So I think I might have gotten this back on time.